Now starting with the next problem of involute. In previous two problems we have drawn the involute for thread, but here the problem is different. We need to draw an involute for a line. Okay, you can assume it as a stick rolling around circumference of the circle. So I'll read the problem and we'll see how to solve such problem. Line AB 100 mm long is tangent at top of the circular disc of 70 mm diameter. The point A is at the top of the circumference. The line AB rolls around the circumference of the circular disc in a clockwise direction. Draw the locus of end A till the end B touches the circle. Name the curve. The problem was asked in December 13 for 6 marks. Now compared to thread, in case of line, both the endpoints will move. In case of thread, one of the endpoint was fixed to the circumference, but here, since that line is rolling along the circumference, so both its endpoint A and B will move. So both the points A and B will trace the curve. So we'll start with the solution. First, I need to draw this line of 100 mm long. Now you have to start at the top because that line is going to rotate in clockwise direction. So I need more space at the bottom. So I'll draw that line of 100 mm at the top, and that line should be tangent to the circle at point A. So I'm just drawing a line of 100 mm. Okay, this line is given as AB, and point A is given at the top of the circumference. So I should draw the circle such that point A is tangent to the circle at the topmost point. So at A, I will draw the diameter of the circle, which is given as 70 mm. So I will measure the diameter of 70 mm. At the same time, I will mark the midpoint of that to get the radius, which is 35 mm. So with this center, I will draw the circle such that it is tangent at point A. Okay. Now the next step is to divide the circle into some equal number of parts. Let us say 8 parts. You can divide it into 12 parts also, but to avoid more number of points and lines, I will divide it into 8 parts. So I need to further mark the angles of 45 degree. So just by producing these divisions, I can divide the circle on other half also. Now after dividing the circle into 8 number of parts, I will name those divisions. Since the line AB is going to rotate in clockwise direction, I'll start numbering in that direction only. So first division 2, 3, 4, 5, 6 and 7. Okay. Now in case of previous problem, the length of thread was not given. So we assume that length of thread is equal to the circumference. But here length of the line AB is given as 100 mm. Okay. So first I need to mark the circumference length along the AB only. So for 70 mm diameter, I should calculate circumference, which is equal to pi d. So it will be 3.14 into 70. So that comes out to be 3.14 into 70 is giving me 219.8. So I can approximately take it as 220 mm. Okay, so I'll mark that length of circumference along AB only. So AB is already marked as 100 mm. So I need to further reduce up to 220. That means 22 centimeters. So almost more than double. Now let us name that point as C. So AB is the length of the line which is going to rotate around the circumference, but AC is the circumference length. Now the next step is to divide the circumference length into equal number of parts as that of circle. So this length is pi d, which is 220 mm, and the AB length is only 100 mm. So we'll show the dimensions here. Okay. Now always remember, we have to divide only the circumference length pi d into equal number of parts as that of circle. Many of the students do the mistake of dividing the length of the line, okay, which will give me the wrong solution. So first I need to divide this 220 mm into 8 equal parts. First I'll check whether that 220 is exactly divisible by 8. It is giving me 27.5. Okay, so I can mark one division of 27.5. No need to follow the acute angle if I can measure that one division directly on the scale. So 25, 27, 27.5. Okay. Now with the same division, I can divide rest of the length into 8 parts. Some error is acceptable. It is okay, it is acceptable. Now I'll name these divisions. Since I have marked 1 here, so I'll name this as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and end part is C. Now you can see the length of line AB 100 mm. The end point A is lying between 3rd and 4th division, okay, on the circumference length. So obviously after rotating line AB along the circumference, the end point B will touch the circle between 3rd and 4th division on the circumference of the circle. So now the next procedure is similar. It was followed in previous problems. So I need to draw the tangents at each point. Now at A, this line is already a tangent. So at at each division, now I need to produce tangents. I am producing in only one direction because we are going to mark the length. Now here it is asked to draw the locus of point A only. We need not draw the end of this curve for B, because B without marking B, I can draw locus of A. But here I have produced that tangent at one on this side, but after rotation on this side I am going to get point B. But I want to trace locus of A, so I should produce that tangent on this side also. So I will produce that tangent on the side of A, because A will be rotated in this direction. So again at 2, I need to produce the tangent in upward direction for marking A, and B will be at downward direction. Then again at 3, I need to produce for A in this direction, for 4 in this direction. Now see here, no need to draw the tangents at 5, 6, 7 because we know that point B is going to touch on the circumference between 3 and 4. So up to 4 is sufficient because in the question it is asked, draw the locus of end A till the B touches the circle. As we are sure that B is going to touch between 3 and 4, so we will draw up to tangents up to point 4 only. Now see here, if I assuming this pencil as line AB, so when I am rotating along the circumference of a circle, the end A, initial position was here, now we will move to this point, okay, and B will come at this line. So the line AB will become tangent at this point, okay. So, but after rotation, for 1/8 division, 1 dash will coincide with 1, and on this side I will get part A1 dash. So I will mark the arc A1 dash on this side to get new position of A, and remaining length, that is 1 dash to B on this side. Remember, you need not take 1 dash to C because we are rotating the line AB and not the circumference. So I should take that remaining length, that is 1 dash to B on this side. So I'll mark the arc to get new positions of A and B because here it is a line, not a thread, so both the points will move. So I'm first taking the distance 1 dash A, and on this side I'll get new position of A, and remaining distance, which is 1 dash B, I'll get on other side of 1. Okay, so I'll mark the new position. This will be A1, new position of A when line has become tangent at 1, and this will be corresponding position for B. So B has shifted from here to here, B to B1. Then moving to the next division means when the line has become tangent at 2, means 2 dash will coincide with 2 and that line will become exactly vertical here. So at that time, A to 2 dash distance, I'll get above 2 and I'll get new position of A, which will be A2, and remaining distance, which is 2 dash to B, I'll get on the other side. So I'll mark the new positions for A, which is A2, and B, which is B2. Then moving to the next division, so A to 3 dash, I have to mark on this side, and remaining 3 dash to B on this side. So I need to produce this tangent to get new position of A. So this point, by coincidence, I am getting it on line AB, but this point is new position of A, which is A3, and this point will give me the new position of B, which will be B3. But still, when the line has become tangent at 3, still the point B has not touched the circle yet. So, but I need to trace the curve till the B touches the circle. So first, I will complete the curve for B. So I'll just join B to B1 by smooth curve, drawing light lines. I'll follow the nature of curve, so it should be smooth. So I'm getting the curve like this. Okay. Now I have reached up to B3, but I'll follow the same nature and I'll continue the curve till it touches circle. So this will be the final position of B. So I'll name it as B dash. Now I need to locate the corresponding location of A when B has touched the circle. So for that, the procedure is I should draw a tangent at B dash. So for that, first I will draw the radius up to B dash, and that at B dash, now I will draw the tangent. So I need to just produce the tangent on this side. Now for A, we have reached up to A3 here. So my curve will be A2, A1, then A2, A1 to A2, then I have to go to A3. Okay. But now to get corresponding location of A with respect to B dash, now when the line has touched B, the length available beyond this B will be the total length AB. So I should take the entire length AB, and with B dash I'll mark the corresponding final position of A, and it will be A dash. So this will give me the position of A when B has touched the circle. So from A3 I need to further produce the arc up to A dash. So though the curve for B is not asked, but to get the final position of B and to locate the corresponding final position of A, I should draw curve for B also along with curve for A. So only this much is asked, nothing is asked about tangent and normal. So now we will just make this curve dark. So for A, I'll make this curve dark. We have just divided the circle into 8 parts. For more precision, we can divide it into 12 parts so that I will get more points on the curve and the curve will be smooth. But if your freehand drawing is good, then 8 divisions are also sufficient, or else you can use French curve. So remember, in case of thread, we are tracing the curve for only one endpoint, but in case of line or a stick, we will get curve for both the endpoints. So this is our required solution for point A. So I will name it as, since it is asked, name the curve. So I will name this curve as the involute. And along with this, we have shown the dimensions of line AB and pi d distance. So along with this, I will also show the diameter of the circle, which is 70 mm. So it will show phi is equal to 70 mm. Okay. Always remember that you have to always divide the circumferential length into same number of parts as that of a circle. Don't do a mistake of dividing the length of a line into 8 parts or 12 parts. Okay. Whatever is the length, it can be either less than the circumference, equal to the circumference, or greater than the circumference. In all the cases, you have to always divide the circumferential length. Okay. Now this completes the solution for this particular problem.